In example number 5, hydrostatic force on a dam. A dam has the shape of the trapezoid shown in figure 6. The height is 20 meters, and the width at the top is 50 meters, and at the bottom is 30 meters. We want to be able to find the force on the dam due to hydrostatic pressure if the water level is 4 meters from the top of the dam. Now we choose a vertical x-axis with origin at the surface of the water, as you can see here in this figure A. The depth of the water is 16 meters. So we divide the interval going from 0 to 16 into subintervals of equal length with endpoints x subscript I. And we choose that x subscript I is in the range of x subscript I minus 1 to x subscript I. Now the ith horizontal strip of the dam is approximated by the rectangle with a height delta x and a width w subscript I, where we form similar triangles. So here we have our depth here, which is 20 meters. Right, which is our height. And we see that here we have our triangle. And so we notice up here we have 10. And then we create this now smaller triangle with a value of A. And then this represents 16 minus x subscript I. And so by using the idea of, again, similar triangles, we're then going to create this proportion and then cross multiply so that we can. And by doing so, we get A, which is equal to 16 minus x subscript I over 2. If we share the denominator, 16 divided by 2 is 8 minus x subscript I over 2. And so W subscript I is going to equal 2 times 15 plus A, which is equal to 2 times 15 plus what we got for A, which is 18 minus 1/2 x subscript I. Again, up here you can see where you're getting the value of 15. And so then if we distribute and then combine like terms, we would get 46 minus x subscript I. So FA subscript I is the area of the ice strip. Then we would have W subscript I times delta x. And what we have found here is 46 minus x subscript I times delta x. Now, delta x is small, then the pressure on the ith strip is almost constant, and then we can use equation 5 to write this. So the pressure is approximately 1000 G times x subscript I. The hydrostatic force acting on the ith strip is the product of the pressure and the area. So here we have the pressure in the area, which is approximately 1000 G x subscript I, times that area, which is 46 minus x subscript I times delta x. And now by adding these forces and taking the limit as n approaches infinity, we obtain the total hydrostatic force on the dam. So by converting this force into our summation, now we can rewrite this into our integral. So we're going from a lower limit of 0 to 16, 1000 times gravity times x times 46 minus x dx. So now we can then factor out the constant, which is 1000 times the gravity 9.8 on the integral that goes from 0 to 16. Distributing the x gives us 46x minus x squared dx. So when we multiply this out, we get 9,800. Take the antiderivative. We get 23x squared minus x cubed over 3, going from the value of 0 to 16, which gives us approximately 4.43 times 10 to the 7th newtons.